So we're going to start section 2.1. Section 2.1 is a definition of the derivative in the tangent line problem. We're actually going to start with the tangent line problem. So what we mean by the tangent line problem is I would like to come up with a way to talk about what the slope of this tangent line is, either at a given point or in general as a function of x. I'm going to start out talking about the definition of the slope of the secant line. So you can see I have a secant line here. I have 2 points. I have one at x and f of x, so it's just an x and a y value. And then I move some horizontal distance h away from that original point, and I have a new point. Now the x value of this point is x plus h, and the y value is f of x plus h. And I can calculate the slope of that line. There's the slope of the secant line. So it's really just y2 minus y1 over x2 minus x1. And that gives us the slope of the secant line. What I want to find is the slope of the tangent line, so I can move this point closer and closer and closer to the original point. And I do that by shrinking that horizontal distance, that h. So I'm bringing that h closer and closer and closer to 0. Right. When the 2 points actually become 1 point, I have a problem. When I calculate the slope between 2 points that are one and the same, I'm going to get 0 over 0, which is an indeterminate form. So actually what I have to do is take that h value and shrink it down, and I'm going to take the limit of this slope as h approaches 0, rather than try to make h equal to 0. That won't work. So basically I'm going to take this expression and take the limit of it as h approaches 0, and that is the definition of the slope of the tangent line. Right. If I take this limit and simplify this expression for a given function, it'll give me the slope of the tangent line as a function of x. If I only want the slope of the tangent line at a particular point, I can use this form by substituting a specific value in for that x. That'll give me the tangent line, or the slope of the tangent line, at a specific point, at a specific x value. Sometimes this is easier to simplify by using that specific value. That's one reason we would do that. Here I've used h as the horizontal distance between the 2 points. Sometimes you'll also see delta x used as the horizontal distance between 2 points. And this is also a very common notation. You'll see this frequently. The only reason we're not using this is because with the delta x, when we expand these, as you'll see in a few minutes, we expand this expression and then take the limit, and using the delta x, it makes things a little bit more unwieldy. So the h kind of cleans things up a little bit and makes it less confusing as we're doing that work.